Hello everyone, this is Mr. Cash. I will be reading chapter 6 from Egan, Fundamental of Respiratory Care. And this is the book, but this is just the front cover of the book, so people who don't know how the cover looks like, this is how it looks like. And it has different editions and different covers. This is the 11th edition, as you can see here. And through this video, I'll just do this as part 1. It will be about 20 minutes long to just read and start from chapter 6. This is basically how I used to study during my school years of respiratory care. And I will start with chapter 6. So the first thing we're gonna do is look at the chapter objectives. And you always have a pen with you or a pencil, or I usually have different colors, but today I'm just gonna go with a black pen and a blue pen. So this chapter objectives tells you what you're supposed to know by the end of this chapter. So the first thing that is telling us, it says here, after reading this chapter you'll be able to, the first thing is describe the properties that characterize the 3 states of matter. So here, as you can see, there are 3 states of matter. You can just underline this right here and keep this in mind, where it says you have to describe and characterize the 3 states of matter. The second thing is telling us describe how heat transfer occurs among substances. And that's another thing that we have to make sure we look back at these objectives and see where we are with all of them. The other one says identify the 3 common temperature scales and explain how to use them. And the other one says describe how substances undergo change of state. The other one says describe how water vapor, capacity, absolute humidity, and relative humidity are related. So here is relating 3 different things. You have to know the relationship between relative humidity and the absolute humidity and vapor capacity, water vapor capacity. So we have to pay attention to this one also. Now the other one says describe how to predict gas behavior under changing conditions, including at extremes of temperatures and pressure. So here it tells you where we have to learn the gas behavior when they go under different conditions, like different temperatures, like very high temperatures and very low temperatures, or also it says different pressures. Now the last one says describe the principles that govern the flow of fluids. So this is actually tells us to see how the fluids flow in different types of flow we have. And then this one says chapter outline. You have states of matter, which is internal energy of matter, loss of thermodynamics, change of state, liquid solid phase changes, melting and freezing. Then properties of liquids, liquid vapor phase changes, properties of gas. And then this one says gas behavior under changing conditions, gas loss, effect of water vapor, properties of gas in extremes of temperature and pressure, critical temperature and pressure, fluid dynamics, pressure and flow fluids, patterns of flow. Then you have flow, velocity, and cross-sectional area, Bernoulli principle, fluid entrainment, fluids, and the Coanda effect. Fluidax and the Coanda effect. I don't know if I pronounced this one right, but that's what it says here. So basically we have 3 sections. We have 4 sections we have to pay attention to. So we need to understand the states of matter, and these 2 right here. Then change of state, which is related to, you see the state and state, you still see it. So relationship we see here, and we're all focusing on what we're supposed to learn by the end of this chapter. Then with this one right here where it says gas behavior under changing conditions, this is this topic right here where it says predict gas behavior under changing conditions, including at extreme temperatures of temperatures and pressures. And then this one talks about fluid dynamics, the movement of fluids, which is this point right here, the last point. Then of course, as always, they give us the key terms. These terms right here, you will see them through the chapter. Throughout this whole chapter, as we read them, you will see all these terms come up here, and when they come up here, they will come up in blue, as you can see here. And we have some of the terms that we need to write them down and understand what they mean, and this is how we're gonna understand this chapter. So let's start reading from the beginning. I know my English is not as my first language, so I'm always gonna be like stuttering at points, or maybe you can say have a hard time pronouncing some of the words, but I will try my best to help you understand this. So this video is basically for students who start in respiratory care and they don't know how to study, and this is my way of studying. So I see this figure here. I'm not gonna look at the figure first, because if I start reading what says under here, I won't understand anything. I will start reading from here, where it says states of matter. There are 3 primary states of matter: solid, liquid, and gas. So I'm gonna underline solid, liquid, and gas. And I'm gonna draw an arrow. I like to write on the side. So I'm gonna put this like that, an arrow. So I'm gonna write here primary states of matter. So this is my main focus is gonna be. So I'm gonna put 1 solid, 2 liquid, 3 gas. So I'm gonna write it down. This is the first sentence, as you can see here. Then it says figure 6.1, which is this one right here. A to C depicts simplified. Depicts means pictures or drawn or something like it. Simplified models of these states of matter. So this right here tells us, the second sentence tells us that this graph is giving us a picture of the 3 states of matter, which is solid, liquid, and a gas. So now, since it's pointed out where it says the figure in the second sentence, so the first sentence is straightforward, is telling us what are the states of matter. So it's telling us there are 3 states of matter: solid, liquid, and a gas. The second sentence right away is sending us straight to this figure right over here. So now I'm gonna go to this figure where it says figure 6.1, simplified models of the 4 states of matter. Now it's saying we have 4 states of matter. So now they added another state of matter. So since they added another state of matter, I can simply add number 4 here, state of matter. As you can see, it's not included in here, but it's also included in here. So this could be a very tricky question that a professor or a teacher can ask you this. So they can tell you what are the states of matter, and they can just give you solid, liquid, and gas. And they give you this, which is now, let's see what it is. It says plasma. That's another state of matter, which is plasma. Plasma, correct? Now, since they gave you plasma as another state of matter, guess what? The teacher can tell you what are the states of matter, and then he can give you just solid, liquid, and gas, and he gives you plasma, and you're not gonna choose plasma within those 3, because automatically in your head you're gonna say it's only solid, liquid, and gas, and that's a tricky question that they give in tests, and a lot of the teachers like to use that. So be very careful that plasma is included here with the states of matter. So it says simplified models of 4 states of matter. As you can see, they said 4. They used the word 4 here. Now, solid rigid network of interconnected springs. So they're pointing out this one right here. This is a solid. A solid is basically anything that is solid, like this pen. This pen is solid. And then it goes liquid, freely moving spheres with no space among them. Now we go to B. This is liquid. Liquid just like water. Water is a liquid. They move freely. Now it says gas, small rapidly moving particles with a lot of space among them. Now you see the relationships that we have here, that a gas, this is the gas right here. Gas, they move rapidly moving particles with a lot of spaces among them. So the molecules within the gas, they have a lot of space between them. Not like the solids where they attach, or like the liquid, they move freely next to each other. But the gas is away, they have a big space between them, and they move very fast. Now let's go to this hidden one, which is D. Plasma, small rapidly moving charged particles with a lot of space among them. And this is D, where they pointed at, right over here. Now let's continue reading this chapter 6. This is how I read this chapter. I'm going to go in details. But if you are looking to read, for somebody to read the whole chapter, I'm going to read the whole chapter without stopping, without explaining anything if I have to. You can click on the link down below. I'm gonna have another video, a whole video just reading chapter 6. This video is gonna be like if you on your if you're working or you're traveling or wherever you are and you just want to listen to me reading this whole chapter 6. If not, you can read it on your own or you do whatever. I'm just saying. Now I'm gonna continue reading. Solids have a fixed volume and shape. Remember, this is solids now. They're talking about solids. They have a fixed volume and shape. The molecules that make up the solids have the shortest distance to travel until they collide with one another. This motion has been referred to as jiggle. Solids have a high degree of internal order. Their atoms or molecules are limited to back and forth motion about a central position, as if held together by springs. And then it tells you about 6.1, what I was just explaining. Solids maintain their shape because their atoms are kept in place by strong mutual attraction forces called van der Waals forces. So they're talking about these forces right here that hold the solid together, and this is the name for them, van der Waals forces. This is probably the guy who maybe discovered them, who cares, but this is the point. This is important. You can the person who invented something, usually they use it on tests most of the time, so I'm just gonna put a star next to it to pay attention to it. So this whole paragraph right here is explaining solids. So when I review, I automatically come back. If I want to know the solids, I go straight to this paragraph and I educate myself on this, and I just keep reading it over and over until I understand what's a solid. Now I'm gonna go to the second paragraph, which is liquids. Now it says liquids have a fixed volume but adapt to the shape of the container. This is a key word here. They adapt to the shape of the container, which means liquids. If you have a cup of water, and then if you have a cup, then you pour water into that cup, the water is going to take the shape of the cup. But as you can see, this pen is already in a shape. This is a solid, so this is the shape. It has whatever it's defined as. So this is the shape for it. This is shape for it. The paper is a shape. That's a solid that has a fixed volume and shape. But the liquid is different. If a liquid is not held within a container, the shape is determined by the numerous internal and external forces. So if the liquid is spilled, if water is spilled on right here on this paper, if I pour some water here, this is what's gonna define its shape. is held within the container. The shape is determined by the numerous internal and external forces. So it's going to be determined by the forces inside the water and on top of it, which is surface tension. That's what they call it, but we'll get to that later. Liquid molecules exhibit mutual attractions. However, because these forces are much weaker in liquids than in solids, liquid molecules can move about freely. No, I think I skipped something. I'm gonna go to the beginning. However, because these forces are much weaker in liquids than solids, liquid molecules can move about freely. And then it sends you to figure 6 to B1, which is here, what I mentioned earlier. This freedom of motion explains why liquids take the shape of the containers and are capable of flow. However, similar to solids, liquids are dense and cannot compress easily. So this is another feature of liquids. So this is what I'll do again, and then I will write here liquids. In a gas, now I'm gonna continue to go into different state of matter. Now we have a solid, and then we have a liquid. So we're gonna move into gas. In a gas, molecular attraction forces are very weak. Gas molecules, which lack restriction to their movement, exhibit random motion with frequent collisions. Figure 6 to 1c. There we go again. Gases have no inherent boundaries and are easily compressed, expanded. Similar to liquids, gases can flow. For this reason, both liquids and gases are considered fluids. Gases have no fixed volume or shape. Both of these qualities depend on the local conditions for the gas. Now, so this is a gas paragraph. So this all talks about gas here. This one right here. This whole paragraph up to this point over here. Now I'm gonna move to the fourth state of matter. Plasma has been referred to as the fourth state of matter. Plasma is a combination of neutral atoms, free electrons, and atomic nuclei. Plasmas can react to electromagnetic forces and flow freely, similar to liquid or a gas. So they have a similar flow as liquid and a gas, plasma. Although mentioned here for the sake of completeness, plasmas are not discussed further because at this time they are not known to be relevant to the practice of respiratory care. So basically what they're telling you here, all they know is that plasma is considered the fourth state of matter, but there's not enough information on this and is not going to be relevant to your studying, which is respiratory care. So they're not going to talk about them anymore. So what they're saying here is most of the time is you're going to be concerned with a solid, liquid, and a gas most of the time. Now the second topic we have here is internal energy of matter. So after I read about the states of matter, I will go back here to the chapter objectives. Now it says here, describe the properties that characterize the three states of matter. Now as you can see, I can now describe and characterize, and I know that also, you see here where it says three states of matter, but I know from here that there's also another state of matter, which is plasma. So I can just put here plasma, right? Plasma. So I just wrote plasma here to just remind myself that when I come to review this chapter right before an exam, I can read here and I see it plasma, so I don't forget that it's one of the states of matter. And now for this one I can check it because I already know. So I can get a piece of paper. I'm not gonna do that. I will let you do that if you're still studying. Now if I was studying, I will get a piece of paper and I will write this first objective, And then I will come here, write a solid and a liquid and a gas and the plasma, and I will give the characterization of them. This is how you characterize them. I will put solid, then solids, and then I will write fixed volume and shape, and then I will write this van der Waals forces. I will write this word, the jiggle, the motion. This is describing the motion, has been referred to as a jiggle. This is what they call the motion between them, and it has a high degree of internal order. You know, I will write whatever is about it. Same thing with the liquid. So I will write about a small paragraph describing the 4 states of matter, and that will be a study card or a study paper just about this and this. And by the time you finish writing them on a piece of paper, I guarantee you already did half of the study, because you just have to review because you understand it now. And then I will move to the second one. So studying takes time, but it's better. You will be way better off than just scamming the whole thing, or not studying at all. Now it's gonna talk about. Now the second topic is gonna be about internal energy of matter. So I will make another video studying this topic, because I have reached 20 minutes for now. Okay guys, I will see you in the next video on the topic of internal energy of matter.